like it's recording? Great. All right, well, good morning, you guys. I'd like to introduce our guest speaker today. This is Quinn Bate, who happens to be my nephew, so of course I can hug him. Quinn's a medical lab scientist. He works down in Sandy at a hospital called Altaview Hospital. And guess what? He went to Weber High School. He actually took my class. He sat right there where Taylor's sitting years and years ago. Graduated in 2001. Oh my gosh, you're old. 2001. When he was here, he did football, he did drama, he was in like the musicals. Chamber choir. Yeah, so he did it all when he was here at high school. So his name's Quinn Bate, as I mentioned before, and he drove like an hour and a half this morning to come, be with us. So we need to definitely thank him for coming. Quinn.
Excellent. Okay, so like Mrs. Radel said, I'm a medical laboratory scientist. And so I think the best thing that we can do is you gotta get the icebreaker and get things going. However, being a scientist, I know the best way for us to get to know each other is to swap fluids. So I need everyone to get out of their chairs right now, come up here and grab a sample so we can swap some fluids. Come on, let's go, let's go. So you're gonna grab the whole beaker. Okay, I'll pass this way. So you're gonna grab your samples. Awesome, that's a friend right there, grabbing a sample for someone else. Excellent, excellent. Okay, excellent. Okay, so I'm glad that you guys are sitting, because you gotta stand up to get around to actually swap fluids. And the best way is to do it this way. You come over to someone, and you should really ask for permissions. Can I swap fluids with you? And then she's gonna take a couple of drops of fluid, and some will go into my cup, back in that cup. Isn't swapping fluids fun? Okay, so I need people to swap over here with fluids, over here. Go around and swap fluids. Can I swap fluids with you? Can I swap fluids?
Yes.
Okay. So go ahead and swap fluids with like one or two more people. And make sure you're.
AJ, do you want some more?
Oh, you're not being too stingy.
I'll give you a little bit. You want some? Yeah.
Okay, go ahead and finish and sit down. No, I want you to hang on to it.
Sorry, I'll do. Give me 2 seconds. 1,000.
Okay, so you guys, this is kind of fun, right? Swapping fluids is so much fun. So what we're doing is you obviously know what I've just done, right? I've contaminated you. So we're going to take some of this indicator and we're going to test the sample. If you turn blue or green, you're okay. If it turns red, that means something else. So I'm going to pass this around. Go ahead and make sure, and it's just a couple of drops for everyone. I'm just going to suck up this one. And you can pass that back and it'll come around the side. Ooh. First victim.
I feel like this side of the room probably didn't mix with this side of the room.
Oh shoot. Well, dead guys.
Why do I have a lot? You weren't giving people any.
You were generous.
Oh.
So do you want to pass that over there?
Sure, where?
Is that being passed back?
Did you guys all get some serum in there?
Did everyone get some?
Like, tell me why.
You just thought you were giving some to people, but you really weren't. Okay.
I was just pretending.
Oh.
It was just a prank.
Guys, I feel like this side of the table, this side of the room had like
And you got something?
contaminated ones,
Okay.
and this side didn't. And
We just
people
mixed.
didn't mix. 'Cause I
Okay,
went
so
over there.
if you look at this, even mine's actually changed a little bit of a color. Okay, those of you that are red, stand up.
Mine's like,
Okay, and you're kind of like a yellow, right?
Yeah.
So just stay right there. Okay,
It
so
was probably mine because I gave mine.
that is great assessment. Go ahead and sit down. If you have like a yellow color, go ahead and stand up. Okay, yellows. I'm in the yellow group. So the rest of you, go ahead and sit down. The rest of you are green. So
I got mine from me.
So as a medical laboratory scientist, when I tell people I'm a medical scientist, they're like, oh, you work at the hospital, you must be a doctor or a nurse. And that's not the case. There's a whole litany of support groups that actually work for the hospital. Medical laboratory scientists, what we do is detect, diagnose, and are involved in the treatment of disease. So this would be like someone got sick, right, with something, and how did it communicate, and where are we at in the trajectory? So why would this sample be yellow if green is normal and red is?
It got mixed between both.
Exactly. So we got exposed versus other people who are actually fully sick, right? So which is pretty cool. So there's multiple tiers within medical laboratory sciences. Medical laboratory sciences is the actual degree when they changed it. The old terminology was medical technologists and medical laboratory technicians.
I'll
Thank you.
just pass this
Oh,
around,
yes.
you guys can put your samples
Yeah.
back in here.
Yeah, you can put those there. Don't want to make you hold on. So we primarily work in hospitals, but we could work in clinics and research facilities, like drug labs and things like that. And then there's a lot of room for like growth and expansion and things like that. I don't want to go too fast. I have so much information to share when I teach students at my work, because I do a lot of training. I start talking really fast, so I'll try and slow down. Okay. Give you guys just a few more seconds.
Thank you.
So let's talk a little bit about the sample that we had, okay? It was a clear fluid. What fluid could that have been from the human body? Any ideas?
Plasma.
Okay, plasma. If you're really, if you were on saline and you were really hemodiluted, normally plasma is more of a straw or a yellow color. But I have seen in like traumas and stuff like that where we're helping people's blood pressure, it can go clear like that. Good option. Anything else? Maybe sweat? Tears? Can we think of any other clear liquid? Saliva. We'll come back to that in a second. Or your cerebral spinal fluid. That's also absolutely clear when we do a spinal tap. So let's go back to saliva. So what kind of thing could we have infected, could we pass with saliva? Can you guys think of any diseases? Mono, also known as?
Kissing disease.
Mononucleosis.
Yeah, the kissing disease or mononucleosis. So, this is kind of what we do as medical scientists, you know what I mean? We're trying to track that. Funny enough, I didn't get mono until I was in college, but that's another story for another time. I actually gave it to my wife. So, job description is we analyze samples from the body. So anytime you go to the laboratory and the doctor draws your blood, we actually do the testing to look at that. And what we're looking for is like a trend. So I'm a chemist. That is my, I'm sorry, I'm sitting in your way. So I'm a chemist. That's the department that I'm over. And so I look for analyzing the blood for chemistries. So if you come into the hospital with a possible heart attack, I would do the analysis on the blood serum to see what your troponin levels or your CKMB levels are. And what we want to know is we want to track trends. So if you come in and are your levels high, are they still going up? So are you having a heart attack? Were they high and are they coming down? Did you have a heart attack recently? And we're just analyzing that. to have you guys understand, there are lots of different fields within medical laboratory sciences. So urine, analysis, blood bank or transfusion services, hematology, we have education, we have point of care. Point of care is kind of like, they use simpler methodologies to try and do the testing at the bedside. How many of you want to go into medicine, know what they want to do? Okay, of those in medicine, what are some things that you want to do?
Ophthalmology.
Ophthalmology, okay.
Anesthesiology.
Anesthesiology, perfect.
I don't know what I want to do.
You don't want to, you don't,
For sure.
but maybe in the medical
Yeah,
field.
for sure.
Perfect. So when I sat in that chair right there, and is it Daily?
Yeah.
Okay, when I sat right there in that chair, I knew exactly what I was going to be. I was going to be an artist for Marvel and Image Comics or DC Comics. But then what happened is I was like, okay, so how am I going to draw the human body better? Well, Leonardo da Vinci studied cadavers and medicine to do that better. That sounds like a smart idea, so that's what I did. And it led me into a career in medicine. All these different fields and departments that we can bounce between. So let's go through my work day. I get up at 4:20 in the morning. I have to be at work at 5 a.m., okay? I go up, check the schedule because of the different departments that I could work in. And when I worked at the big hospital in Murray, RRL was huge. We had special chemistry, serology, flow, mass spec, chemistry, hematology, all these different departments. So I'd check the schedule and find out where I was working, and then what I would do is I would go to that department and I would start maintenance. Maintenance could be cleaning, documentation, making adjustments, restocking reagents, making sure that for the next 24 hours everything was going to work perfectly for all the colleagues that were going to work on that bench. The next thing that I would do with that machine, or machines, and normally that's what it is, it's plural or we're covering multiple departments. So chemistry has PCR, a lot of the manual tests that we perform. So the first thing I do is I'll calibrate and do quality control testing. Now, let me kind of describe what calibration is. Calibration is, if I were to represent this mathematically, we have the analyzers, right? And analyzers are kind of like a television screen, right? There's electronic components, there's the screen, there's electricity going into it. My analyzers have tubings, mixers, probes, water bath temperatures, and all these different things. So there's the analyzer. On the other side, we have the reagents. And a reagent is specific for whatever we're testing. So let's say we're testing for glucose, right, to see what your glucose level is. The manufacturer makes up that glucose. Who here has a favorite cookie? Cookies? Anyone? Cookies? What's your favorite cookie?
Like a sugar cookie.
A sugar cookie?
Yeah.
Okay, so let's say that we're making sugar cookies, right? So we get our flour, we get our sugar, we get our salt and everything, and we mix it together. And we bake up a batch of sugar cookies, and we're eating those cookies, and we're like, oh, this is amazing. We want more sugar cookies. So we're gonna go back, and we're gonna put the same amount in, mix it up, and rebake it. Is it gonna be exactly the same? No, there's gonna be slight amounts of variance, right? So what calibration does is it establishes the relationship between our reagent, and that is lot specific, and our analyzer. Mixers, lights, lasers, tubings, and all that stuff. And we try and establish a linear mathematical set so that we could come back with our control, and we'll pick something that's low, in the middle, and something that's high, to prove that if we get this reaction, it calculates to that value. And that proves to the government that we have control over how the machine is working. One of the most difficult things I have to teach or to explain is the science that I do isn't like an ER room, right, or an operating room. A lot of people think that science works as like, if it's a scalpel, if it's sharp, it'll cut, it's gonna work. That's not what's going on here. There's a delicate balance here that I have to do for every department and every analyzer that I run and every test that I run. If anything is abnormal, I have to follow up and find out why. So I'm doing detective work, seeing what needs to be changed. So let's say something terrible happens and a mixer breaks. I might have to go in and change that mixer, which would then make me have to re-establish a relationship with that reagent to fix it. So what we do is we allow tolerances on the high and the low end, and this is how much we can be low, this is how much we can be high for each analyte. So regardless of how many patients I test that day, I do this for every machine in my laboratory, or all my colleagues do. So if someone's sick, I'm now having to run back and forth and do that to make sure that we're ready for testing. And that can take till about 10:30. I'm doing that whether I see one patient or 1,000 patients. So then once we're able to run tests, I will then look at the test results and watch them and monitor them. Critical values will be repeated. This is where it could be lethal. We'll look at a patient's history. So if something changes abnormally, so let's say that hematocrit's really high and it drops really, really low in a short amount of time, we're looking for someone that's bleeding or things like that. And then we might treat. So if someone has like lipids in their blood, we might treat it to resolve it so that the way we do tests actually work. The methodologies that we use are a lot of them include light, color change, or electrical impulses. Have to do with how our testing does. So then I would go ahead and continue on with manual testing. Validations is like establishing that for a new process, and then just covering other departments. Now, when I get into work in the morning, there's someone who's already been there for 10, 12, 14 hours working the grave shift. I would talk to him or her and say, hey, what's going on? What is things looking like? And they'll tell me where people are at and everything like that. Okay? So this is my lab. I walk right in the door. This is a smaller lab. Central Lab was a huge lab. I worked there for many years, about 6 years. I've been working here for almost 7. So here's the entrance to our laboratory. So if we were to hook around to this corner, here's chemistry. This is Quinn. This is where I sit. You can see I have my main analyzer here. I have a backup, PCRs over here. We have some reagents, some logbooks, another analyzer, and manual bench. And this is where I basically do all my analyzing of things, my computer screens. So I would sit there, go into the storeroom, collect any supplies I need after looking at what the machines need. I check the water. We need really, really pure water. If we have any, I talked about those electrical impulses. If you have water that's coming from like a tap, those anions and cations can affect how the sample actually works. And how they actually could interfere with it. K, daily logs. Every system, every machine, every bench that we have has a log. If we didn't write it down, it didn't happen. And so we'll log everything, every temperature check we did, every cleaning that we did, and everything that we performed. It all gets calculated. I'm an advanced medical scientist, and I'm over the chemistry work group with chemistry. So I do this not only daily, but I look at the monthly things, and I draft up like huge reports for all the calibrations, the QC, and all the logs for the medical director. So it keeps me pretty busy. I was actually on the phone this morning. We were having a problem at work, and I was making sure it got sorted out. Before I go on, questions, concerns, or insults? Okay. So this is my big machine. So this is my main chemistry analyzer. And so in the morning, I would open up these lower doors and check for the large consumables. And these pistons, probes, these are 1 ml syringes. I would check the bellows, making sure nothing's leaking, nothing's abnormal. We have had problems where like something bad happened, and I had to figure out what was going on. What's up?
What was that called again?
Which one?
That machine.
It's called, you want me to be technical?
or whatever, you sure?
They call it the AVAI1. Yeah. So it's an architect, and let me scroll back. So that's a really good question. So this side does electrical impulses and colorimetric changes. That's how we do our analyzer. This one is fancy. It builds a sandwich and then emits light, and we capture that light that comes off. You're like, Quinn, that's really specific. Why does that matter? So, have you guys ever seen like a chocolate milkshake or like a strawberry milkshake, right? Where it's all like milky and clear. So if someone has pancreatitis, they can't pull the fats out of their bloodstream, their serum will look like that. So here, where we're changing colors, it's not going to work very well because it's going to impede the method that we're doing the teaching, or the testing. Whereas here, because we're building a sandwich, and then we wash out the plasma after we've bound what we're looking for, the light's going to emit and it's not going to matter. So this methodology isn't affected as much by lipids as this one is. Kind of cool, huh? So if any of you that are nurses or doctors or stuff like that, we're like, hey, we're treating this specimen, it's going to take a little bit longer to do stuff, or we're doing dilutions. Let's say that your CK is super, super high. We might run it to this endpoint in the linearity and then have to dilute it back down and then use math to multiply it to where it should be. Because a lot of times this math, it'll drop off where it's no longer linear for some assays. Great question. That's an awesome question. But technically it's an architect. C1 4100, so nerd stuff. All right, so let's go. So here's the top of the machine. So this is on that color side. I have these specialized quartz glass carousels. Oops, touch screen. Sure. I have my mixers here. This is my washer nozzles. This is where that electronic impulse happens. And this is where like some of our samples are put in. I'm going to switch over to the other side real quick. So here's looking at it from the other side. I've actually even had with these mixer blades, it broke off inside one of those containers things, made a whole big mess. So then what I had to do is find out when it happened and do a look back, pull all those patients. I was working at Central Laboratory. We run 4,000 samples a shift. 3 shifts, 4,000 samples. Bad day, right? So we had to go back, find all those patients after we fixed the problem, repeat them, and make corrections for all of them. Plus the 4,000 samples we were already doing from that day. Yeah, it sucked. And then there's a whole bunch of paperwork that we had to do and everything like that. But this is kind of like the idea of what we do to make sure that we're putting out really, really good, accurate results. Because if we were to tell you that you have a condition that you don't have, being treated would be really, really terrible. Okay, so on my machine, so this is like our daily. So when I went into that machine, this is around that C side. We check those 1 ml syringes at the bottom, make sure they're not leaking. Also, that there's not bubbles where they shouldn't be bubbles. Because if you're drawing air, you're changing the relationship with those values. Checking the DI water, hey, we did that this morning, right? We went into that room and checked it. Daily maintenance is just really a wash. We're cleaning out to make sure there's no carryover between those quartz glass. And then checking for those mixers. We actually built this and added this later on because we broke a lot of mixers. And so we found that to be a problem, so we added that to our test menu.